So this is a review for the 3.5 and 3.6 test. I'll go through it and hopefully clear up any questions you have, and you'll find this helpful so that you can make sure you're ready for the test. So first thing we did on this was we solved the system of equations by using a graphing calculator. Now, it's really important on the test that you follow the instructions. So when it says use the graphing calculator, use the calculator, then you want to just use the calculator. You don't have to show any work. So for this one, we can just go to the Desmos for 1 and 2. And it doesn't make any difference what those equations are. We just type them in. So I'm going to go and just make up a problem. Y equals 3x squared plus 5x minus 6. And then I'm going to plug in another expression. And let's go y equals negative 2x squared plus 4x plus 6. Okay? And so you just type them into the Desmos calculator, get your two graphs, and then we are looking for the intersections of where the two graphs cross, so where the blue and the green graph cross. So that would be, and now when you write your answers on these, some of you are just putting the x values. You have to put the x and the y when you're solving a system of equations because we have two answers, so you have an x and a y. So one solution is 1.452 and 7.591, and the other one is negative 1.62652 and negative 0.6071. So when it says to use the graphing calculator, it's pretty easy. Type the expressions in, find the intersection points, and write those down. So then, next, to solve the equations by substitution, 3 and 4. So when we're solving by substitution, so let's just take the first equation. X squared plus y squared equals 49. And y equals 7 minus x. So the first thing we do, solve for one variable. Okay? So we solve for one variable. It just means you want to get one variable by itself. In this case, you should always don't do the x squareds or the y squareds. Always do just an x or y. So in this case, y is already by itself. So we've got that done. And then once we have that, we substitute that value into the other equation. So I'm going to take this value for y and plug it into the other equation. So we get x squared plus, when I come to y, I replace it with 7 minus x. In parentheses, equals 49. The next thing you do is solve for x. Now, I'm not going to go through completely solving this, but I will tell you a lot of people make this mistake. The squared, remember, means times itself. So I have to take 7 minus x times 7 minus x. So then I have to plot or FOIL it, whatever you do. And so we get x squared plus 49 minus 14x plus x squared equals 49. So to do that, let's set this equal to 0. So x squared plus x squared is 2x squared minus 14x. Now I'm going to move this 49 over here because I want to set it equal to 0. That's how we solve for x, set equal to 0. And then from here, you can either factor it, you can use the quadratic formula, any of the things that we've used before to find the zeros. And if you need review on that, that is in 3.1 to 3.4, and you can go to that review to find that. But you find the value for x, and then once you find the value of x, let's go ahead and just finish this one. So in this case, I'm going to do it by factoring. I can pull a 2x out of both those and get x minus 7. And so either 2x equals 0 or x minus 7 equals 0. And so divide by 2, x equals 0, add 7, x equals 7. And so that tells me my values for x are 0 and 7. And so we've got our two values, and now we solve for y, which just means we plug these back into either one of the equations. Okay, I can plug it into this one or this one and solve for y. It'd be much easier to solve it in this one, so you just plug in 0, and 7 minus 0 would be 7. And plug in 7, 7 minus 7 would be 0, and our answers would be 0, 7, and 7, 0. All right? So, that's by substitution. By elimination, we've already gone through elimination. We did that with 3 by 3 equations. And so if you need review on that, you can do that in Unit 2. So we'll go to the Unit 2 review. Or wait a second. No, the Unit 1 review. So if you need review on that, go to Unit 1. We did 3 by 3s there, but these are 2 by 2s. You do it the same way as when you got it down to 2 equations. So I'm not going to review that again. If you need that, you can go to the Unit 1 review and find that review there. 7 and 8 seem to cause problems for people. It says to solve the equation using a calculator. Again, we're using the Desmos app. All you need to do on these is take the left side and right side and split it into 2 parts. So I just go y equals 2x squared minus 12x minus 16. And then I take the other one and I set it equal to y. Negative 6x squared plus 60x minus 144. And once you do that, it's just like numbers 1 and 2. So there's no difference between this and the first 2 problems. It's just written differently. So you make each part equal to y and then plug them in. So this would be the same thing if I went back up to this and I put this in for y. It'd be the same thing. We're just kind of doing it the other way now. So you write it as 2 equations. You plug it into the calculator, and that will give you the answer when you find the intersection points, just like you did on 1 and 2. So that's the same. On graphing the inequalities. Now, remember, this doesn't say to use the calculator. Now, you can use the calculator to find things if you want, but what you have to do is you have to give me a chart, and I don't care how you get the chart. You can do that using a calculator. You can do it by doing the negative b over 2a to find the vertex. So like on this one, that would be 0 divided by 2 times 1 is 2, so that would be 0, and negative 9. And then I could plug in 1 and get negative 8, and negative 1 would be negative 8. And I could plug in 2 and get negative 5, and so negative 2 would also be negative 5. And I can get that, and so then you graph it, and so at 0 we're at negative 9, at 2 we're at negative 5, and it's greater than, so that's a dotted line, so I'm looking for a dotted line there. And then what you have to do is you have to show me. So you can get this chart on the calculator, but then you have to test a point. Now again, I always recommend testing 0, 0, and else it's on the line. You can pick any point you want, but I'm going to pick 0, 0. And so I test it. And so I plug in 0 for x and 0 for y, and so I get 0 is greater than 0 minus 9. Is 0 greater than negative 9? And then the answer is yes. Well, if the test point works, then I want to shade where the test point is. So since the test point is inside and it worked, I want to shade inside. If I didn't get this working, then I'd want to shade outside. So that's what you do on 9 and 10. And then on 11 and 12, it's the exact same thing. You just do, just like I did 9 and 10 on 2 separate graphs, I'd put them on the same graph, and then wherever they both overlap. Now, this isn't the answer to this, but let's say this graph looked like this, and this graph looked like this, and the test point worked inside this graph, so inside this one, and it worked inside this one. Well, the answer then is the overlap, where they overlap, which would be in here. Okay? If it was outside this one and inside this one, then that would be that section. And if it was inside this and outside this, then it'd be that section. It's just wherever the two overlap. Now again, this isn't the right answer for this graph. It's just an example. Because we do it the exact same way we did this. You're just going to have two charts here and then two test points. And then the last part is solving inequalities algebraically. And so you have to find the two values that make this equal to 0. And you can do it by either using the quadratic formula or factoring. I prefer to always try factoring if it works, but it doesn't always work. And so we have to take, in this case, x squared plus 10x plus 9 is less than 0. And I'm going to try it by factoring. So that would be 9 and 10, which would be 9 and 1. So that would be x plus 1 and x plus 10. And so my answers are -1 and, x plus 9 and -9. So now what I do when I'm doing these algebraically is I do a number line. Again, it doesn't have to be perfect. -9 is to the left of -1. And now I have to test a point inside each one of these and find out if it works. So let's pick -10. So I plug in -10. Well, -10 squared is 100. 10 times -10 is a -100. And 100 minus 100 is 0. And a 0 plus 9 is 9. So I get 9 is less than 0. And that is not true. So I put no. Now I test a point inside. So I'm going to test -2. Okay, so I plug in -2. Well, -2 squared is 4. -2 times 20 is a -20 plus 9. So that'd be -16 plus 9 is a -7, which is less than 0. So that is true, so it works, so it's yes. And then I'm going to check a point outside it, so greater than -1, so I'm going to plug in 0 because that's fast. Again, I get 9 is less than 0, which is not true, so that's no. And so then I finally write my answer. Since it's in between, I put x is less than -1 and greater than -9. If this would have had a less than or equal to sign underneath it, then I would have had to put that underneath those. Now, if it came out, let's just take 2 and 5. Let's say it came out yes, no, yes, then I write it differently. Then x is less than 2 or x is greater than 5, because it can't be both at the same time. So if it's the outer two, then you write it this way with an or in between. But that's the review for 3.5 to 3.6. Hopefully that helped. Again, you should have the answer sheet, but in case you don't, these are the answers. So you can see those. You can pause it after you get your review done so you can check your answers. Again, if you don't have the review, this is the review, the practice test, so you can, again, pause the video here to write those down. There's 1 through 6. There's 7 and 8, so again, you can just pause that to get those. And then the back. There's 9 and 10. And 11 through 14. So if you don't have those, you can still do that, and you can still check your answers because you've got the review. So hopefully that's helped, and you're able to get that done and then come back and be able to do the test when you get back. So thanks, hope that helped.